Cement is one of the most essential materials in modern construction, forming the backbone of roads, buildings, bridges, and countless other structures. But have you ever wondered how this gray powder is made? The process of manufacturing cement in a factory is a complex, high-temperature operation that involves several precise steps. Let's take a deep dive into the fascinating process of how cement is made. The first step in cement production starts with the collection of essential raw materials. The key ingredients required for manufacturing cement include limestone, clay, and other minerals such as silica, iron ore, and bauxite. Among these, limestone is the most crucial component, accounting for nearly 80% of the total mixture. It is extracted from large quarries using controlled blasting techniques to break it into manageable pieces. After blasting, heavy machinery like excavators and loaders is used to gather and transport the raw materials efficiently. Once collected, these materials are then moved to the factory through conveyor belts, dump trucks, or rail systems, ensuring a continuous and reliable supply for the next stages of processing. Once the raw materials arrive at the factory, they go through a crushing process to prepare them for further processing. Giant crushers are used to break down large limestone rocks into smaller, more manageable pieces, making it easier to handle and process them efficiently. After the initial crushing stage, the materials are transferred to grinding mills, where they are finely ground into a fine powder known as raw meal. This finely ground mixture ensures a uniform texture, which is essential for maintaining consistency and quality in the final cement product. The finely ground raw meal is then directed to the preheater tower, a tall structure consisting of multiple cyclones arranged in a series. As the raw meal moves downward through the tower, it encounters hot gases rising from the kiln. These gases transfer heat to the material, gradually reducing its moisture content and partially heating it before it reaches the main kiln. This process not only improves efficiency, but also helps conserve energy by utilizing the waste heat from the kiln, making the overall cement production more sustainable and cost-effective. Next, the finely ground raw meal enters the pre-calciner, a high-temperature chamber where additional heat is applied to initiate a key chemical transformation. During this stage, limestone begins to decompose into calcium oxide, releasing carbon dioxide in the process. This decomposition is essential as it prepares the material for the next phase, making the overall process more efficient. Now comes the most critical stage, clinker production. The preheated and pre-calcined materials are fed into a massive rotary kiln, a long, rotating cylindrical furnace capable of reaching extreme temperatures of up to 1,450 degrees Celsius. Inside the kiln, intense heat triggers a series of chemical reactions, gradually transforming the raw meal into small, marble-sized pellets known as clinker. These clinker pellets are the fundamental building blocks of cement and will undergo further processing before becoming the final product. The intense heat inside the kiln causes the raw materials to melt and fuse together, setting off a series of chemical reactions that form new compounds, which are essential for cement's strong binding properties. As the kiln slowly rotates, the partially molten material moves gradually toward the exit, where it begins to cool and solidify into small, rough-textured pellets known as clinker. By the time the clinker reaches the end of the kiln, it has taken on its final granular form, but is still extremely hot. It is then discharged onto a specialized clinker cooler, where powerful airflows rapidly reduce its temperature. This controlled cooling process is crucial, as it helps maintain the clinker's structural integrity, enhances its reactivity, and prepares it for the next stage in the cement manufacturing process. Once the clinker exits the kiln, it remains extremely hot, with temperatures soaring up to nearly 1,200 degrees Celsius. To safely handle and prepare it for further processing, it undergoes a specialized cooling process. The clinker is transferred to a clinker cooler where powerful fans forcefully blow air over the red-hot material, rapidly bringing down its temperature. This quick cooling process reduces the heat to approximately 100 degrees Celsius, ensuring that the clinker is both manageable and structurally stable. Additionally, this step enhances the clinker's reactivity, which is essential for producing high-quality cement. Proper cooling not only preserves the clinker's chemical properties, but also improves overall efficiency in the final stages of cement production. After cooling, the clinker is stored in silos or warehouses until it's ready for the next step. At this stage, the cooled clinker is mixed with a small but essential amount of gypsum, which plays a crucial role in regulating the setting time of cement, preventing it from hardening too quickly. This carefully measured mixture is then sent to massive ball mills or vertical roller mills, where it undergoes an intensive grinding process. Inside these mills, heavy steel balls or rollers crush and grind the clinker into an ultrafine powder, ensuring a uniform texture and the right chemical composition. This precise grinding process is vital, as it determines the final cement strength, consistency, and overall quality, making it suitable for construction and various industrial applications. Once the cement has been finely ground, it's stored in large silos before being packed into bags or loaded directly into bulk containers. The cement is now ready for distribution to construction sites, concrete manufacturers, and other industries. Factories use advanced automated packaging machines to fill and seal bags efficiently. These bags are stacked on pallets and transported via trucks, trains, or ships to various locations worldwide. Cement production is an energy-intensive process, but factories are working to reduce their environmental impact. Many modern plants use alternative fuels like biomass, waste materials, and recycled industrial byproducts to reduce carbon emissions. Additionally, factories are developing eco-friendly cement blends that use less clinker, which helps lower CO2 output.